So let's recap significant figures and kind of what we use them for. So significant figures serve a couple of purposes. One is that it helps the scientist in proper rounding when we're dealing with mathematical operations of data. And also, it is very much tied to scientific notation. And scientific notation is easier to understand in the context of significant figures. So we have 5 basic rules about numbers that are significant. And I'll assign each one of them a number. So rule 1 is that all non-zeros in a number are significant. Rule number 2, all zeros between non-zeros are significant. 3, trailing zeros that don't follow a decimal are not, and I put AR instead of ARE, not. And that is because we can easily replace trailing zeros with scientific notation, such as in the case of 160,000, and we just chop it down to 1.6 times 10 to the fifth, and that follows the rules of that our base of our notation is two significant figures, 1.6, 1 and 6. Leading zeros also can easily be replaced by scientific notation, so we can get rid of those 3 leading zeros in 0.000267 and just say 2.67 times 10 to the negative fourth while keeping the non-zero digits, okay? And then rule 5, well, and this is a rule that tends to get forgotten a lot, is that zeros after a decimal place are, such as in the case of 432 with 3 zeros, which would represent thousandths of whatever the base value is. And this really only makes sense if you're thinking of it that these numbers actually represent something. So it would not really make sense for those 3 zeros to be there if we were representing just things that are whole numbers. But if we have, like, say, a scale that measures to the thousandth of or 10,000th of a gram, and we put something on the scale, and it really, really does come out to exactly 432, and then all 3 of those decimal digits on that scale turn up zeros, well, then that's a legitimate use of trailing zeros. So to summarize how you could apply these, I made a little table of 4 examples, 4 values: 909.0004570, 34,500, and 0.09066. So the first one, 909, that has 3 sig figs because of rules 1 and 2, and we can turn that into notation 9.09 times 10 to the second power. The second value only has 4 significant figures because rule number 4 tells us that we get rid of those leaders, and we can turn the remaining values into notation. That trailing zero is significant because of rule number 5. 34,500, that's 3 sig figs. We can get rid of those 2 trailing zeros and write it in notation. And then the last value, we can get rid of that leading zero because of rule 4, but the zero between 2 non-zeros, which is rule 2, does apply, and we can put that into notation as well.